So the next section about object-oriented programming that I want to explain is inheritance. Now let's make something more complex. About the inheritance, suppose there is a class student. You know, there can be many kind of students. For example, there are 3 students, undergraduate students, undergraduate Aksa, graduate student, Dhyakwon, and exchange students, Yuan Aksen. Then, what are the difference? So there are difference in terms of the status. So if you are a undergraduate student, it means it is a 4 years school and you need to maybe complete 100 something credits. Okay. For graduate school, maybe you need to complete 30 credits. Okay. So maybe in this undergraduate, you need to complete 140 credits, something. The graduate school, you need to complete 30 credits. For the exchange students, it depends. If the exchange student is only for 1 semester, maybe they need to complete 12 credits. If the exchange happens for 2 semesters, maybe they need to have like 24 credits, for example. So every student will have different kind of data, but all of them are students. In the class or in the object oriented, you can create something like this. Now, I do not use the encapsulation. Okay. Let me just omit encapsulation in this case. The encapsulation means the data will be in private, but let me just put all of them in public. Okay. I have the data, which is the student name. I have the data about student age. I have the data about the student grade. I have the S type. So S type is the student type. And I want to also declare the tuition fee because the tuition fee will be different between the undergraduate, the graduate, and the exchange students. And the number of credit that you need to take. Then I have the name, the age, the grade, S type. Let me make a default value, which is undergraduate. Let me make the tuition equals to 0. Let me make the credit equal to 0 for the default value. But later on, you can change because this is the parameter. So you can define the data. This is the class diagram. The class name is student. And we have the attributes name, age, grade, S type, tuition, credit. And the method that we have is the constructor get name, get age, get grade, get credit, get tuition. Okay, get name, get age, get grade, get credit, get tuition. Using this class, you can have the client code. So there are 3 students. So let's say this is the undergraduate student U1. This is G1. This is the graduate student. And let's say this is exchange student. Yeah, now I would just give the numbers randomly. For example, the student Park, his age is 20 and the grade is A0. Maybe this is the final grade. And this is the undergraduate student. This is the tuition, and this is the number of credit that he needs to take. And this is the graduate student, Lee, the age and the grade. And then this is the student type. He is a graduate student. This is the tuition fee, and then this is the credit. And E1 is an exchange student. And then we have the information about name, John, age, and the grade, along with the tuition and credit. So if I want to know the details about U1, then you can print. Okay, you can print the student U1. You can get the name, you can get the age, you can get the grade, you can get the credit, you can get the tuition. Oh, the type. Do I declare the type? Maybe this is no. Okay, let's see the code in the Google Colab. Maybe I put the type. Okay, so if you want to print the student U1, then you have U1. For all objects of U1, you can call the method, and then you can get the information. If you want to get the student G1, so you have the G1 as the instance, and then you call the method. When you want to know the information of the exchange student E1, you can call the object and then call the method. Okay, then you can get the output. You can get the output like this one. So let me check the Google Colab. Okay, I have the get type. So I don't put in the PowerPoint, maybe because of the space. Then I can do the instance generator. So I create an instance. This is another instance. This is another instance. So if I call the get name, get age, get grade, get credit, get tuition, and get type, we got this value. If I call the G1, we got this value. If I call the E1, we got this value. Okay. Now, using the class concept like this one, this is okay. But you need to maintain a lot of things. Let's say I have the undergraduate student and I want to maintain only the undergraduate student. I have the graduate student and I want to maintain only the graduate student. I have the exchange student. I want to maintain only the exchange students. So we can create the inheritance. Inheritance means it allows a new class. Okay, there will be a new class, or we call it subclass or derived class to inherit properties and behaviors, or sometimes we can say method from the existing class. The existing class, or we call it superclass, or the base class. It is a way to establish a relationship between classes. Okay, so what does it mean? Let's see. I can create the student into this concept. Let's suppose this is just a simple example to show the superclass and subclass. We have the superclass or the student, which is the base class. It means every student will have name. Every student will have the attribute age, and every student will have the attribute grade. And you can get name, you can get the age, you can get grade. We have subclass. So the subclass indicates that it is a different concept or it is a different class, but some information or there is a general information that it refers to the student class. So undergraduate student will have name, age, and grade. The graduate student also have name, age, and grade. Exchange student will have also the name, age, and grade. Because this is a relationship. Undergraduate student is a student. The graduate student is a student. The exchange student is a student. And in order to do this one, we can create like this. It means this is a new class, this is another new class, and this is another new class. Whenever you create the undergraduate student, you need to refer to the constructor from the superclass. When you create the graduate student, you also need to create the instance based on the constructor on the superclass. When you create the exchange student, you also need to create the constructor based on the superclass. We have name, its grade, name, its grade, name, its and grade. And we have this one. In the inheritance, we have the class student. This is the example that I showed you before. We have the constructor. We have name, its and grade, name, its and grade. And we have three methods: get name, get its, and get grade. Now we need to have three different classes. So the first class is undergraduate. The second class is graduate. And the third class is exchange. The class undergraduate, it is a student. So we call this is a relationship because undergraduate class, it will follow the general information in the student class. The graduate student will follow the general information from the student class. The exchange student will follow the general information from the student class. So we call this is inheritance. The undergraduate student inherit any properties in the student. Graduate student inherit any properties from the student. Exchange student inherit any properties from the student class. And when we try to construct the object, when we try to create an instance of undergraduate student, so we will have name, age, and grade, and those things referring to the super. So what is super? Super is the superclass. If we have student in this case, then the superclass is student. So the superclass, we have the constructor, its name, its and grade. So the super, which is student, we will construct based on the constructor that we already defined in the superclass. The graduate student. The graduate student, it inherits from student, and for the constructor, we have name, age, and grade. And again, we construct an object, and the constructor follow the super. The super class is the student. The same with the exchange student. The exchange student, it inherits the student properties, and the constructor of this exchange student, it follows with the parameter name, age, and grade, and it goes to the super class. We construct the name, age, and grade from the super class. Now let's see. When we use the inheritance, okay, we have the student, we have name, age, and grade, we have get name, get age, get grade. Now I'm creating three subclass. Okay, the three subclass is the undergraduate student, the graduate student, and exchange student. The undergraduate student, we have the constructor, and the constructor will follow the information from the student class. So super means the super class. This is super and this is super. So when you run, you can create the object based on the information from the respective subclass. Now I'm creating an object of undergraduate student. It means I don't need to declare anything. And once I know that this is an object of undergraduate student, every properties of the undergraduate will go to the U1. Graduate, it means every property in the graduate class, it will go to G1. Exchange, every property in the exchange class will go to the object E1. Then if you run, for example, U1, I want to get this one is just a grid. Okay, this is just a grid. This is just a grid because I still have no information about the method. So let's see how can we define this one. The shaper class is the same as the common class. So it shares the common properties. It shares the common attributes. It shares the common methods. For example, the students. The student have name. Students have age. Students have grade. The subclass should have the parent class. It means this is the subclass undergrad should have the parent class. The parent class is the student. It calls the superclass super. So it calls the superclass super and follows the constructor init. It follows the constructor init, which is from the superclass. And it also requires the parameters as defined in the superclass. When the superclass requires three parameters, name, its grade, then you need to have also the value name, age, and grade, so you can create the instance. So if you look at this one, okay, if you look at this one, we call the undergraduate. This is the class of undergraduate. And if you look at the class undergraduate, if you look at the class undergraduate, is there any method get grade? Is there any method get grade? No. The get grade you can see from the class student. So there is no get grade method in the undergraduate, but you can call. You can call U1 get grade because the undergraduate class already inherit the properties from student class. In the student class, you have get name, get age, get grade. It means when you declare the inheritance from the undergraduate class, you will have the get name, get age, get grade from the student class, and you can use it in the undergraduate object. In the G1 is also the same. G1 is graduate. Is there any get grade in the G1 or in the graduate class? If you look at the graduate here, it is only the constructor. So using the super, it means we construct the object based on the student class, and we inherit all the methods or all the data from the student class. The same with the exchange student. E1. The exchange student is also a class that inherits from student class. Then we can get any method from the student class. So this is the output after you call the method. Basically, you can call any method from the student class. So let's say I want to E1 get name. Then you can get the name. Even though now the exchange, the E1 is exchange. In the exchange class, there is no method get name. But the method get name is from the super. Super means the super class. This is the super class. You can get the, for example, G1 dot get age. So I can get the age of G1. G1 in this case, the graduate student 25. And even though the G1 is the object from graduate class, and the graduate class has no get age, we can get it from the super class. The super class is the student, and we can call the method get age. So that's the meaning by the inheritance. Now, when we deal with the inheritance, we can create more details like this one. And we call this is abstraction. The abstraction means that for every data that we declare, let's suppose we have a student and we have name, age, grade, as type, tuition, and credit. So this is the same with the first example that we look at, and we have the methods. So the methods is the constructor, get name, get age, get grade, get credit, get tuition, get type. In order to split each of the student, we have three different classes: undergraduate, graduate, and exchange. So you can use this one. It means whenever we create a new student, we will directly classify. Okay, if the student is undergraduate, then we use undergraduate. Okay, if the student is graduate student, then we use graduate object. If the student is only an exchange student, then we use the exchange class. In order to calculate, in order to create the object, then we need to use all the information. For example, the name, the age, the grade, the student type, the tuition, really. So we call this is using the abstraction. Okay, we call this is using the abstraction. So all the data that we want to create, we will declare based on the data on each of the class. We call the class graduate and we declare the information based on the class. And we have the class exchange. We have the data based on each of the class. So we use the abstraction to create each of the object. And all the data will be in the superclass. All the data or the attributes are in the superclass. Okay, so here all the data are in the superclass. So the data in the undergrad, the data in the graduate, the data on the exchange will follow the data on the student. So we call this is the abstraction. Each of these data will be based on the particular class. Each of the data will be based on the particular class. Each of the data will be based on the particular class, and we can do definition later. Okay, if you do with the abstraction, okay, I think I need to move this one. I need to explain this one first. So this is the section about the object-oriented with abstraction. It means I have the constructor. I define every of the data, name, age, grade, and the type, and the tuition, and the credit. And then I have the get name, get age, get grade. So this is the abstraction. So the credit will follow the object. If it is graduate student, the credit will be different. It follows the tuition from each of the object. If it is an exchange student, they have different tuition. If it is a graduate student, they have different tuition. If it is a undergraduate student, they have different tuition. With the same class, so I'm just giving only the constructor. So the constructor, now we have to define every of these attributes: name, age, grade, student type, tuition, and credit. For the undergraduate student, for the graduate student, we have name, age, grade as type, tuition, credit, the same. And for the exchange student, we also have name, age, grade as type, tuition, credit. Then we can have this information, like say the undergraduate, we define the undergraduate. For the graduate student, we define the graduate student. And for the exchange student, we define the exchange student. And for every of this one, they have the same information. You can call the U1. As I mentioned to you, we have the get name, get age, get grade. And we can also call the get credit, get tuition. We can also get the name, age, and grade for G1. And we can also call the name, age, and grade, credit, and tuition for the E1. Okay. Now, let's suppose I have a new student, E2. E2 is an exchange student, and let's say the name is Bob, and the age is, let's say, 19. And let's say the grade from his previous university is A0. He is an exchange student. And what about the tuition? Maybe the university have some rules. Okay? The rules, if they are exchange student, they have the similar tuition. So the undergraduate, student, all the undergraduate students, they have the same tuition fee. All the undergraduate students, they have the same credit. It means I can say that the exchange student, they have the same tuition fee, which is 3,000, and they have the same credit, which is 12. Now, if I have another student, E3, then, okay, let me just use this one. What happened? The information, this one, will be the same. The information, this one, will be the same. If I have E4, for example. So the information here are the same. Okay. Only the personal information is different, but the information related to the exchange student, they are the same. The student is exchange, the tuition fee is this one, and the credit that they need to take this one. He is a exchange student, and the tuition is 3,000, and the credit that he needs to take is 12. The tuition is 3,000. The number of credit he needs to take is 12. So all information are the same for the exchange student. So in this case, we can try to do something, not repeating this one. So this is repetition. Even though we use the abstraction, but if it is repeated, yeah, we can try to remove the repetition. How to remove the repetition? Yeah, so the first one, we write all the data and methods in the super class. Okay. So if necessary, subclass has overlap methods to change the values. If necessary, the subclass, it means the student, we have the undergraduate, we have the graduate, and we have the exchange. For the subclass, which is the undergraduate, we can have the overlap methods to change the value. For example, here we have cat name. So you can have, sorry, not cat name. Maybe it's not good with the cat name example. Let's use the cat tuition. Okay. Cat tuition. Because every of these students, they have their own tuition. Then you can also have the cat tuition. You can also have another method here, cat tuition, because the tuition might be different. In the exchange student, we also have the cat tuition. Okay. So tuition, do you know tuition? Yes, 학비. Okay. So 학비는 달라요. 대학생, 대학원생, exchange student. 학비는 달라요. So if it is in the student class, it means that all of them will have the same tuition. However, actually they are different. So we can have the overlap methods. Overlap method means in the super class we have the method. In the subclass we also have the method. Or instead we can write the specific data and methods in the subclass. So we don't need to write all the data in the superclass, but we can write the specific data in the subclass. How? So we can make something like this. For the student class, we can just keep the general information. The general information means name, age, and grade. So every student, of course, they have name, they have age, and they have grade. But for the undergraduate student, we can define based on the attribute, the data, and also the value. For example, let's suppose the undergraduate student, the tuition is fixed 6,000. Maybe if there is a change, maybe if there is a scholarship, yeah, they can have some changes. The number of credits is 140. It is fixed. So we can define the data in the undergraduate student. For this undergraduate student, we can have two methods. In this case, get tuition and get credit. However, in the graduate student, the tuition fee is a little bit higher. Let's say 7,000. And the credit that the graduate student need to take is 30 credit. So it is less than the undergraduate student. And thesis is yes, okay, non-moon. So for graduate student, they need to submit a thesis. Yeah. That's why we have the information yes. But for the undergraduate student, there is no need to submit any thesis. Then we can have a different method in the graduate student. For the exchange student, the tuition is less because maybe they will be in the school only for one semester. So the tuition is 3,000. And the number of credits, it depends. Maybe for one semester, it requires to have 12 credits. And okay, for the exchange student, it requires the Korean language. So we have yes. It means the general information we can refer to the student, but for each of the category, they can have different data. They can have different data. They can have different data. And they can also have different method. They have different method. For the exchange students, they need to have the Korean language. For the graduate student, they need to have thesis. But for the undergraduate student, we have only the data about tuition and credit. So we can apply the inheritance. Every of those subclass will refer to the superclass. But for every of this class, they will have their own method and they will have their own data. So using the, oh, I didn't share the code. So let me get back to this. This is the object-oriented with abstraction. Now I have the detail. In this case, I'm having the undergraduate student and I specify the tuition is 6,000 and the credit is 140. And I want to get the tuition, I want to get the credit. For a graduate student, I want to specify the tuition is this amount, the credit is 30, and there should be a thesis. For the exchange student, okay, the maximum credit is 12, the tuition is this one, and it requires the Korean language. So every subclass, they have their own data, they have their own method. Wait, I think I need to, I need to make this. Okay, I need to call this one again. Because every time I call the different case. Then I can create the student. So I create the undergraduate. I create the graduate. I create the exchange. The idea is the same. So the result will be the same. I can get the name, age, and credit. The credit and the tuition, it refers to the undergraduate, which is the credit and the tuition that we declare in the class itself. Now let's see if I create the graduate student. Okay. G1 is graduate student. For U1, can I get the thesis? Print U1. Get, there is no thesis. Okay. Because we don't specify the thesis here. But for the G1, okay, we have the G1. So I want to print G1 dot get. You can specify get thesis, because in the G1, which is a part of the graduate student, yeah, we can have the thesis. What about the exchange student? E1. We have name, its grade, graded tuition, and then because we specify another requirement, which is Korean language, so I can also call the Korean language. So I can call the Korean language, and the result is yes. But can I get the Korean language for the graduate student? Get Korean. This is different. It will be error because the graduate object has no attribute Korean language. Only the exchange student E1 has the Korean language method. Yeah, if you refer to this one, it's of the object. It's of the subclass. It's of the subclass. We can define our own data. We can define our own method, but the general information still refer to the subclass. So the inheritance, okay, it is very good if you can understand the inheritance with your unique data and methods in subclass, because we can write the general data and methods in the superclass, and the subclass has specific data and specific methods. With this kind of concept, it is easy to extend with another subclass. For example, in the university, okay, there are some new types. For example, a double degree student. Then you can create a new class, double degree with particular data. For example, the double degree with the tuition, this one, the credit is this one, no requirement for the Korean language. And the degree will be only for the IME, maybe the CSE, computer science, and BME. So you can just specify with the class double degree, and it can inherit the student. Or maybe there is also another class, which is part-time student. So part-time student means the student is allowed to join the online class because part-time student. Then we have another data about the online class. So using this inheritance, it is good if you have multiple subclass. So the code reusability. So you don't have to rewrite the common code. Name, age, grade, yeah, they are common. So when you use the inheritance, you don't need to rewrite it. You have the student class one time and all subclasses inherited. The modularity and the organization. It helps organize your code into hierarchical structure, making it easier to understand and maintain. And extensibility. It means you can easily add new type of student. So for example, part-time student. We have a new student type, part-time student. You have new type, double degree student. So it is easy to create new subclass without modifying the existing student class. And it refers to the polymorphism. It means the object of different classes that share a common superclass can be treated as object of the superclass. So if it is the undergraduate object, they can get any properties from the student class. Okay, so this is the polymorphism. So you could have a list of student objects. It could contain instances of undergraduate, graduate, and exchange. And you can get the get grid, which is from the student class, even though the undergraduate, the graduate, and exchange student, they don't have the information about get grid. And yeah, as I mentioned before, it reduces redundancy. So when you inherit the common features, you avoid duplicating code. So you don't need to write many codes at the same time for every classes, which reduce the chance of errors and makes updates easier. Okay. Okay, for the practice, let's see tomorrow. Okay, I will continue with the practice tomorrow. So tomorrow morning, in the first hour, we will do practice. In the second hour, we will do the quiz. Okay. Any question?